In this video, we're going to be adding in the player controls.
So, for this, we'll jump back to our project panel, right-click, go Create, C# script, and call this Dropper. Open up Dropper, and this is going to be our player component, essentially. It's going to be the marker of where we're dropping the next sphere. So, in this one, we're going to create a few variables, pretty much start to finish. We're going to go float max radius, and we'll say that that is 13, and this is going to determine how far away the dropper can get from the center of the volume. We'll go public float dropper speed, and this will be how fast can we move the cursor. This will depend largely on your input mechanism and what you want the game to feel like, but 12 will be fine. Public rigid body RB, public bubble prefab, which will be the objects that we're spawning to drop into the scene. Public float drop cooldown, and we'll say we can only drop one every half a second, and we want to keep tabs on what the current cooldown is, so we'll go current cooldown. And we also want a reference to the current bubble, so the one that the dropper is currently holding. So we'll go public current bubble. So when the dropper starts up, we want it to start with a bubble. So we'll go current bubble equals instantiate bubble prefab transform. So this is setting this object as the parent for my bubble prefab. Okay, so we want to set a random score value for this bubble. So basically it can do anything from the current score value up to a certain point. So we'll go current bubble dot bubble value equals, and we want this to be an integer, mathf dot max, and we might actually do this with a animation curve just to give us a bit more control over the likelihood of any given value showing up. So we want the low values to show up a lot more. We want to weight it towards that. So we'll go public animation curve bubble score curve. So mathf max somewhere between 1, which will be our minimum value, and bubble score curve dot evaluate, and a random number, random dot range between 0 and 1 as floats. So somewhere along that line, multiplied by the merge manager dot instance dot maximum score, so the highest value that we've achieved so far. I am missing a parenthesis right there. So essentially this is going with a minimum value of 1, get a random point on that curve, and then multiply it by the maximum score, which means that we can basically weight the likelihood to be toward the low or toward the middle with just a visual interface in the inspector. We're going to set up our bubbles when we spawn them, but we'll just go current bubble dot rigid body is kinematic equals true. So we want to be able to control this without physics interfering. Current bubble dot bubble collider dot enabled equals false. So we don't want the bubble that we're holding to interfere with this stuff in play. And the current cooldown is going to equal the drop cooldown, just to give a initial time for the game to sort of get started. Okay, so we're going to have a bubble that is attached to our dropper. So we need a dropper object. So game object, create empty, and we'll call this dropper. and the dropper will have a dropper component attached to it. It doesn't have a current rigid body. It needs a basic bubble, so we'll add our Suika bubble to our prefabs. So in assets, create a new folder, and we'll go resources, and create a new folder inside that called prefabs, and then drag our Suika bubble into that. And then on our dropper, we're going to drag from the assets panel, not from the scene, into our bubble prefab. And we're going to set our bubble score curve to the exponential scale upward. Okay, so close that, and these two are pretty much ready to go. I'm just going to preemptively, on our collider object, I'm just going to turn that off just by default. There's our dropper. Let's put that up to a value of about 13. There we go. So we've got our dropper object sitting up above our scene. That object is kinematic, so it's not falling just yet, but we do still need to buy just some bits and pieces to make sure that things are going to behave nicely. We're also going to, because we've turned off the collider here, we're going to say active bubble is false on the prefab. So this means that it's not going to trigger any collisions and any score functionality while it's being held. Right, so let's add in player controls. So if we go up to Voxon Input Manager, we're going to have our custom input manager. And the reason why it's important to use the Voxon Input Manager is that it's very common for Unity Voxon applications to run in headerless mode. That means that there's no Unity window to listen for inputs to come through the Unity application. So this basically sort of detaches the input listener so that we can listen for it even when the VLED runtime has priority. It works sort of somewhere as a mid-ground between the legacy input manager and the new input manager. So basically we've got our different input fields here. I'm going to work this for a keyboard input. You have options for gamepads, up to 4 at the moment. Obviously we're looking at whether we can expand this in a flexible way, but we'll see. We can do mouse inputs, we can do space nav inputs. So the space nav only has the button inputs here, and then we have a different listener for the 6 degrees of freedom stick. However, for this, we're going to be using the keyboard input. So I'm just going to create a new input here, and we'll call this forward. And the key will be set to W. And then I click add, and I can create a new entry. So we'll go back. And this will be on S. And I click add. So I'm just going to rattle through all of these. So that's all I need for this. If I need to modify an input, I can just click on edit, change whatever field I like, and click update. This will save whenever we input anything in, and it will save to a JSON file in the streaming assets folder. So if you want to modify the JSON directly, or if you want to copy it between projects, that's your avenue. So with that, I can just close that, jump back to my dropper script, and we'll go vector3 move vector equals vector3 dot 0. And now we can just rattle through our controls and add each input to the move vector. Now if I'm doing this with a gamepad, then I can do this with a get axis, but since I'm doing it key by key just for compatibility, we need to do it key by key. So if Voxon dot input, so this is using the Voxon input manager, dot get key. Now we've got very similar options to the Unity input manager, so we've got get key down, get key up, get key work pretty much identically. We also have get button down, get button up for joypad inputs. mouse button, space nav, so it's all sorted in that. So we want get key to listen out for when the forward key is held. And we'll go move vector plus equals vector3 dot forward. So this is just working on a global directional system. Now you can do things where you've got like each player faces a specific direction, so you do a transformation on the input to make the game work on the same inputs for a different direction. So in this case, I'm just going to duplicate that 3 times, and we'll go back, and that will subtract forward, and then right, and that will add right, and left will subtract right. Okay, so that just gives us a nice neat move vector that we can deal with, and then we're going to go in vector3 new position equals transform dot position plus our move vector multiplied by the dropper speed multiplied by time dot delta time. So now we just need to make sure that when we're measuring distance for this, it's sort of only measured laterally. Like we don't want to sort of measure the distance from the center from a sphere. We want to do it from a circle. So we'll just go vector2 flat pos equals new vector2, and that will be our new position dot x and our new position dot z. Now, if the flat pos dot magnitude, so since we're measuring this from the origin, we don't really need to do anything of like distance to the capture volume, is greater than the max radius, then flat pos equals flat pos dot normalized multiplied by max radius. So this is just capping it back at that maximum radius. And then we can unpack this back into the new target position. So we'll go transform dot position equals new vector3 flat pos dot x transform dot position dot y. So we're keeping it at the same height, and flat pos dot. So that should give us enough to move around. And I'm just going to add a child object. So create 3D object. We'll go as cylinder, and we'll just call this aim. And we're going to make sure that that's it. Cool. So I'm going to move this down 10 units. I'm going to make it 20 units tall. And let's say 0.3 in the Z and X. It has no collider, and we will give it a material. So we'll come into our materials folder, we'll just duplicate the M bubble, and we'll call that M aim. I'll color it red just for visibility and add that to my aim. Add the aim as a child of the dropper. So my dropper is at let's say 15 units high. We might modify this later, and my aim reticle will be at -10, a little bit lower. Just so that we've got something to see where the balls are going to drop. So I've got my aim reticle attached to my dropper. My dropper object is as it was. We've got our input controls set up, so I should now be able to use WSAD and move my aiming reticle around the screen, and I've got a rough idea of where it's going to fall. Cool. So coming back here, that's working now. So from here, we're going to handle the drop logic. So we'll go if current cooldown is greater than 0, then we will count down the countdown. So minus equals time dot delta time, and return, because we don't need to do anything after this point because it's all the drop logic. We do, however, need to add in a drop button. So jumping back to Unity, let it rebuild, Voxon, input manager, new entry, drop, and we'll put this onto space. There we are. And add, can close that now. So if Voxon dot input dot get key down, so only on the down event, drop. We're going to basically do a check radius initially. That's just going to make sure that it's not currently overlapping with something, because that can cause some messy collisions if we try and sort of turn it onto a physics object when something is in the way. So we're just going to say float check radius equals 1.5, so like just enough to keep it out of the center so that it's not absolutely throwing everything anywhere. We're going to get a log of anything that is going to be overlapping in this radius. So collider array, we'll call it hits, equals physics dot overlap sphere, transform dot position, so at the location of the dropper with our check radius. So if it does hit something, then we want to abort the drop. So we'll go for each var hit in hits, rigid body, so we're going to get the rigid body of the hit object, RB, because we're not using it here, equals hit dot attached rigid body. And if RB is not null, so there's something overlapping it, and the rigid body is not kinematic, and the rigid body is active, so just sort of doing some filters to make sure that we're not getting false positives, active in hierarchy. If I can spell. Then that means that we're overlapping with something in our scene that is going to cause problems. So we're just going to go abort the drop and return. Okay, so we've just hit a drop button. We've checked to make sure that it's valid. So we need to do two more things. We need to drop the current bubble, and we need to make a new bubble. So current bubble, and we're going to be saying this a lot, so I'm going to copy this. Transform dot local position equals basically we want to stop bubbles from dropping perfectly on top of one of each other and stacking like a snowman. So we're just going to very quietly nudge in some direction. Equals random dot inside unit sphere times 0.0003. This is just going to, from its current position, which is local to the dropper, it's just going to nudge it randomly in some direction so that they don't fall perfectly. We're going to say that the transform.parent is now null, so we are releasing it from the dropper. Current bubble.rb.is kinematic equals false, because we no longer want to control it directly. Current bubble dot bubble collider dot enabled is true. So we're turning on the collider. And now this is a bubble that's in place. So we'll go current bubble dot active bubble equals true. So we have now released this bubble into the capture area. The next thing that we need to do is set up for the next drop. So we'll go current cooldown because we have successfully dropped a bubble. Current cooldown equals drop cooldown. So setting that back up to the maximum, which will count down again once it comes through to here. We will make a new bubble. So we can grab this from the start, come up, and paste that in. And this should now be ready to go. We have a new bubble instantiated. So I've just realized my mistake. I've said get button down instead of get key down. So hit play. And now I get the option to drop these. And so when they hit a match, they will merge, and I can sort of try and nudge them together. And we've got a basic Suika game.
Thank you for joining me for this tutorial series. I'm absolutely thrilled to be able to share the pipelines and processes that we've been working on to make volumetric game development as accessible as possible. If you've followed this tutorial, or if you've built or migrated your own projects to work on a volumetric display, we'd love to hear from you. You can find all of our handles in the description below. I'll see you next time.